I think a lot of our intuition is based on thinking of nature as having a kind of continuous character. So if you take a pencil and you bend it slightly, it bends. You push a little bit harder and it bends a bit further. There's a direct link between what you do and what you get out. There's a cause and effect relationship. So small causes should have small effects, big causes have big effects. But what crises are, and what science has realized, is that the world is kind of full of systems that don't work that way. So your pencil, if you bend it far enough, will suddenly and abruptly snap. So it goes into a total different regime of behavior. And understanding these kind of points where the behavior goes from one kind of thing that's very predictable and understandable to a totally different kind of scenario is what a lot of science is now trying to understand. You have these crises in financial systems, you have sudden traffic jams on the internet or on the roads, you have collapse of populations in ecosystems and that kind of thing. All these systems have points where they can go from one kind of qualitative behavior to another kind of behavior, and it's very difficult to see these crisis points coming in advance. Maybe the best conceptual example is just what physicists call a phase transition, say in water. So we have a water molecule is a very simple object, two hydrogen atoms and an oxygen atom. You could study a water molecule for the rest of your life, and many people do, in fact, in physics, understanding all the properties of the specific molecule. But there's nothing in that study that would ever give you the idea that at some point, if you heat up liquid water, there will come a transition when suddenly it will turn into a gas. Or likewise, when you cool liquid water to the freezing point, suddenly and abruptly and without warning, that system will have a collective behavior that suddenly changes from a liquid where it can flow to this solid thing that is hard and resists someone pushing on it and becomes slippery. So there are new qualitative kind of properties that just come into existence suddenly without your ability to predict them. This kind of emergence also affects us in our own lives. So, for example, I mentioned the idea of a traffic jam on the roadway. Everyone's had this experience. You're driving along, suddenly the road seizes up. You drive for 10 minutes very slowly, and you never actually find anyone who caused the traffic jam, and then you come out the other side. That's very similar to what happens in systems such as water, where you get this collective organization that suddenly changes. Right. I think the biggest concept for me, the thing that I think people don't realize, is that what we recognized about complex systems is that you shouldn't expect linear, gradual, slow, steady change. You shouldn't expect what you see in the future to be just a copy of what you've seen in the past. Systems such as ecosystems, the Earth's crust, the Earth's atmosphere, traffic flow, they're all characterized by very large, unpredictable fluctuations in the system behavior. And those fluctuations are just normal and natural. And so a huge traffic jam isn't necessarily an unnatural or out of normal behavior, just like a huge earthquake is something you should expect. And large mass extinctions at the same point have happened all throughout history, just as an ordinary part of biology. So large fluctuations is a part of the natural dynamics of complex systems. We're all used to thinking about averages. If we look at people and get the average height, that gives us a good ability to understand how people are and what we should expect in the next person that comes along. Lots of things in the world work that way, and averages are good ways of thinking about them. But lots of things don't work that way. So if you look at say, websites on the internet and look at how many links a particular website has, you find that there is no well-defined average, or the average is just a kind of useless concept. There's such huge fluctuations, with some websites having hundreds of millions of links to them, other websites having only one or two. In fact, many have only a couple links to them. That the average number of links just gives you no good information about how the web is linked together. Same thing is true in epidemiology. When you look at the number of people to whom one person is potentially linked, say, in spreading a virus. There's huge differences, and you really need to take those huge differences into account if you're going to understand these kinds of systems. There's no theory of everything. It's not all chaos. It's not all order. Some things are chaos, some things are ordered. So you find on a city street where pedestrians are walking in both directions down a narrow pathway, you get a spontaneous formation of lanes. You get some people walking in narrow lanes one direction, others in another direction. They intersperse in a very orderly kind of fashion. Over time, however, you kind of see drifting and shifting of those lanes, and there's a chaotic flow to the system. So you have order that is kind of locked into a system that is also disordered and chaotic.